Okay, so with simultaneous equations, we have two methods to solve it. So first, we're just going to use the substitution method. So to begin with, we must label the equations as 1 and 2. So equation 1 will just be x plus 2y is equal to 2. While equation 2 will be 3x plus 3y is equal to 15. Next, we have to take one of the first two equations and rearrange it such that one of the variables the subject. So in this case, we'll take equation 1 and make x the subject, such that equation 3 will give us x is equal to 2 minus 2y. Now we create this third equation such that we can substitute it into one of the other equations, in this case equation 2. So as we can see in equation 2 we have 3x, while in equation 3 we have a single x. Therefore we have to multiply equation 3 by 3 such that it's 3 times 2 minus 2y plus 3y is equal to 15. Next we simplify it such that it's just 6 minus 6y plus 3y is equal to 15. We simplify it and move the constants to the right hand side and we get minus 3y is equal to 9. We divide everything by minus 3 and we get y is equal to minus 3. Next we substitute y into one of the three equations. Now it's clearly visible that equation 3 would be the simplest to attain x. Hence we'll just have x is equal to 2 minus 2 times minus 3, which gives us x is equal to 8. And therefore we have x is equal to 8 and y is equal to minus 3. Okay, this time we're going to use the elimination method. So as we can see that the 3x does go into the 15x, it's just that the 3x has to be times by 5. So we'll take the 15x minus 7y is equal to 1 first, and then we multiply the first equation by 5 to give us 15x plus 10y is equal to 55. Next we'll minus these two to give us minus 17y is equal to minus 54. Next we'll divide both sides by minus 17y and give us y is equal to 54 over 17. Since we know what y is, now let's go back and find x. So if we use elimination again, we note that the y's do not go into each other, and hence we'll have to create a new multiple for them. So if we multiply the first equation by 7 and the second equation by 2, we'll create a common multiple of 14. So the first equation times 7 will give us 21x plus 14y is equal to 77. While the second equation times 2 will give us 30x minus 14y is equal to 2. Now if we plus these two together, we'll get 51x is equal to 79. And therefore x is just equal to 79 divided by 51. Next, moving on to question 3, we have y squared minus x squared is equal to 72 and y squared is equal to 2x squared equal to 40. Using substitution for this pair of equations, let's just make the y the subject from the first equation to get y squared is equal to 72 plus x squared. Now substituting this into the second equation, we will get 72 plus x squared minus 2x squared is equal to 40. Moving the constant to the other side and simplifying, we'll end up with minus x squared is equal to 32 minus. Now let's just take the minus off of both sides. This will just give us x squared is equal to 32 and x is the square root of 32. Now simplifying this, we'll end up with the root of 16 times root 2, which is just 4 root 2. Now looking on the first equation again, let's just substitute x back into it, but let's take x squared is equal to 32. This is so that we can simply substitute it in and we don't have to square anything again. So from the first one, y squared minus 32 is equal to 72. Y squared is equal to 104, and y is equal to the square root of 104. Now if we look at 104, is there anything we can divide it by such that we will get a square? There is. We can divide it by 4 so that we get root 4 times root 26, which will give us 2 root 26. And that will give us x and y.